Aloha Algebra 1 students, this is Unit 10 Radicals. And for this unit, we're going to be using a radical booklet that you can pick up in class. Okay, so this is what the first page of your radical booklet looks like. And this unit is called Radicals because we're going to be looking at square roots. And another word for square root is called a radical. Now, the reason we call this a radical is because radical comes from the word radix. And in Latin, radix means roots. And so square root, cube root, this is just another way of saying radix or radical. Now, this part of the radical, I'm going to always refer to it as the house. It looks like a check mark with a line going across. And again, I'm going to call this the house. Underneath the house or inside the house, we call this the radicand. So the radical is the house, and inside the house is the radicand. On the left of the house, we will have some number, and we call this the index. Now, we actually have seen the index in a different way. Sometimes we see it as a cube root, or we see this as a fourth root or a quad root. If there is no index, so if there is no number there, and this is what it's going to look like. And because of the software I'm using, this is another way to see a square root. It doesn't have this line that goes over that kind of makes the house, but this check mark is in fact a root. So when we have no number in the front of it, when there is no index, we assume that this is a square root, or n is equal to 2. So the index is a 2, which is a square. Also, if a radical has more than one root, the radical sign indicates only the principal or positive root. So in a second, you're going to see that the opposite of a square root is a square. And when we square something, if it's positive or negative, it'll always end up being positive. And so this is why we always take the principal or the positive root from that square root. When you get into higher math classes, they'll teach you, they'll go into a deeper way of looking at square roots. But for now, we're just going to say it's going to be the principal or the positive root. Now, perfect squares. Looking at a perfect square, it's going to be any number that has been squared. And so here we have 1 times 1 is 1 squared equals 1. 2 times 2 is 2 squared equals 4. 3 times 3 is 3 squared equals 9. So it's any number multiplied by itself. It will become a perfect square. Now, let's go ahead and list the first. Actually, I'm going to make you go up to, let's go up to 16. Let's see if we can do up to 16 or 15. Let's go 16. Okay, so let's list the first 16 perfect squares in this box. And I started it off for you. 1 times 1 is 1. So 2 times 2 is 4. 3 times 3 is 9. Continue this with you and your group. Go ahead and pause the video if you need. Okay, so you should have written down all of the perfect squares. And this is what it looks like. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256. And again, it's a number multiplied by itself. So 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and all the way up to 15 times 15. Okay, before we go into this next section, I actually want you to pull out your calculator and just practice square rooting something on your calculator. So the first thing you're going to square root is the square root of 256. Now, we actually see this here, and we know that we went up to 16, and so we should get the answer of 16. So in your calculator, you're going to press the square root button, and you're going to press in 256, and you should get an answer of 16. Okay, let's go to the next one. It's a square root of 169. Again, in your calculator, you're going to press square root 169, and you should get 13. Okay, last one. Try it on your own. Square root of 5776. 5776. Okay, what answer did you get? Okay, you should have gotten the answer of 76. Is it 76? I think it's 76. Okay, let's move on. So in your booklet, right below, we have perfect square roots. Now, perfect square roots are just like the ones that we wrote out on our paper. So in your calculator, let's pick it up. Let's figure out what is the perfect square root of 16. And here we know that what number times itself is equal to 16? It's going to be equal to 4, because 4 times 4 is equal to 16. Okay, let's go to number 2. When we see a number and a square root attached to it, this really means 2 times the square root of 121. 2 times the square root of 121. So when we write it out, we're first going to write the outside number outside the house, which is 2. And what is the square root of 121? We know that it is 11. So 2 times 11 is equal to 22. Okay, let's go to number 3. Again, we have 6 square root 289, and this means 6 times the square root of 289. So I'm going to separate them out. I'm going to put first 6, and then in my calculator, I'm going to figure out what is the square root of 289. Okay, you should have seen that it is 6 times 17, because 17 times 17 is 289. I'm going to multiply 6 and 17 together, and I'm going to get 102. Okay, for number 4, go ahead and do it on your own. Again, we see it as 3 times the square root of 400. We're going to write it out as 3. Square root of 400 is 20. So 3 times 20 is equal to 60. Now, you could actually punch this all into your calculator and get a whole number. So let's go back and let's just try it on your calculator. Let's try 2 root 121, and you should get the answer of 22. In your calculator, try 6 root 289, and again, you should get 102. And lastly, try 3 square root 400, and you should get the answer of 60. Now, they call these perfect square roots because your answers are whole numbers and there's no decimals. Again, because they're whole numbers and no decimals. If at any point you punch this into the calculator and you do get a decimal, you are going to simplify your square root, and this is what we call a non-perfect square root. Non-perfect square root. So, number 5 is an example of a non-perfect square root. And we know that because try it in your calculator. Square root of 32. I'm going to try it here. Actually, no. Try it in your calculator. Square root of 32. And you should get some number that is between 5, about 5 point something. Because 32 is between 5 and 6, it's going to be like 5 point something. Now, because there's a decimal there, we actually cannot write square roots with decimals. We're not going to do decimal answers. We're actually going to write them with the radical symbol. So if it doesn't become a perfect square root, we will have a radical in the answer, and I'll show you what that means. So again, we did not get a perfect square root, so we're going to find the largest perfect square root or square that has a radicand that is divisible by this number, 32. Now I'm going to put my perfect squares here, and these are my roots. And I just like to have this available so when I look at 32, I can say, okay, what number goes into this? And we're looking for the largest number, So below 32, we have 25. Does 25 go in there? No. Does 16 go into 32? Yes, it does. And it goes in by 2. So if you put 32 divided by 16, you should get the answer of 2. So I'm going to take this house of 32 and I'm going to split them into 2 houses. I'm going to split the house into a house of 16 and I'm going to split the house into a house of 2. From here, I'm going to take the square root of the perfect square. So I know that my perfect square is here. The square root of 16 is 4. And I'm going to leave the leftover under the radical symbol. And what that means is we're just going to take root 2. And because this is square root of 16 times the square root of 2, this becomes our answer. 4 is outside of the house and 2 is inside of the house. Because 4, we were able to cancel this out from 16, and 2 is our leftover. And so leftovers stay in the house. Okay, let's go to 6. 6, we have 180. Again, if we punched the square root of 180 into our calculator, we're going to get a decimal. In fact, it's going to be around 13 point something. We know that it's between 169 and 96, and so it's going to be 13 point something. So because we're going to get some decimal answer, I need to go to my perfect squares and say, what is the largest perfect square that I can divide into them? Now, when it has a big number like this is what I like to do. I like to pull up a scientific calculator and I like to just start doing my options. 180, and I start dividing them by roots. By perfect squares. I know that I have a 100. Nope, that's 1.8. Okay, I'm going to clear it. Go 180 divided by 64. Nope, 2.8. 180 divided by 81. Nope, 2.2. 180 divided by, what else do we have? 64, 49, 36. Ooh, let's try 36. Perfect. I came up with a whole number. And this is what we're looking for. So I know that the biggest perfect square for this is 36. And the other part is going to be 5. Okay. So let's get back into here. Okay, so again, I'm looking at 180, and I know that it can be split into 2 houses. It's going to be split into the house of 36. And it's going to be split into a house of 5. And again, 36 is a number that I can easily square root. Square root of 36 is going to be equal to 6. And then I have left over 5 and I can't get rid of it. And so I'm just going to put 6 root 5, and that's my answer. 6 times root 5, or 6 root 5. Okay, let's go down to the next example. Number 7. Number 7 is the square root of 147. So again, I'm going to do the same thing. I'm going to go to my scientific calculator, and I'm going to say 147 divided by 16. No, 147 divided by 64. No, 147 divided by 36. No, 147 divided by, no, it's not 25. 49. Let's try 49. Oh, very good. So our biggest is going to be 49. So I can split my house of 147 into 49 and 3. Okay, so again, I'm taking my 147. I'm split it into a house of 49 and 3. And this says that the square root of 49 is times the square root of 3. I know that I can cancel this out. Square root of 49 is equal to 7. And there's nothing that can cancel this radical. And so the radical is just attached. 7 root 3. Okay, let's go to number 8. 175, if I'm looking at that, I know that 25 would easily go into 175, and none of these because I have an ending in 5. And so 175 divided by 25 is 7. So I can divide this house into 25 and 7. Again, I can simplify the square root of 25 into 5. And what's left over? My leftover is just my root 7. So my answer is 5 root 7. Okay, let's go to number 9. Number 9, I'm looking at 48. And as I'm going below 48, I have 36, 25, 16. I actually know that 16 goes into 48. And so 48 divided by 16 is going to be 3. So I can break this up into a house of 16 and 3. 16 and 3. I can simplify 16, so I'm going to get 4. What's left over? Root 3. So my answer is 4 root 3. Okay, for number 10, we have this example 2 times the radical 54. 2 times the square root of 54. Again, this is a non-perfect square. And so just like we did previously in the examples at the top, I'm going to actually bring what's outside of the house down. And then I'm going to decide what can go into 54. Here, 54 sits about here. And the biggest number that can go into it evenly is actually going to be 9, because 54 divided by 9 is 6. So I'm going to split it up into this root 9 and root 6. And here, what it says, 2 times root 9 times root 6. When we have all these numbers together, they're really multiplied together. And an easy way to make sure that you're not messing up is to put parentheses around them. So we know that it says 2 times root 9 times root 6. Okay? So what can we simplify here? I can simplify 2 times root 9, which is 2 times 3. What's left over? My root 6. 2 times 3 is 6, and so my answer is 6 root 6. So this is how we simplify 2 times root 54. We get 6 times root 6. Okay, these 4 questions, I'm going to have you do them in your group together. Again, if you're on a paper where we don't have perfect squares, an easy thing to do is before you get started, just start labeling like the side of your paper going downward or across the bottom, just your perfect squares, so that it's easy to look at these numbers and say, oh, this is the largest number that goes into one of these. Okay, so you're going to work on these on your own, and then when you're done, go ahead and start the video again so you can find the answers. Okay, so you should be done with all 4 of them, and here are your answers. We have -5, and we're going to split 150 into root 25 and root 6. And we're going to say -5 times root 25, which is 5, times root 6. And this will equal to, this should be -25 times root 6. Okay, I just have to fix it really quick. Okay, so it's -25 times root 6. Okay, this next one, we have an 8 times root 128. And you should have figured out that 128 splits into 64 and 2. And so simplifying root 64, that's equal to 8. So 8 times 8 is going to be times root 2. 64 root 2. And that's my answer. 64 root 2. Okay, 13, we have -3 times the square root of 28. Again, I'm going to drop my -3. And 28 actually breaks up into 4 and 7. So I have a root 4 and a root 7. And what this is really saying is -3 times 2, because this simplifies the 2. I'm going to drop the other things here. -6 times 2, -3 times 2 is -6 root 7. And lastly, number 14, we have 4. And again, you need to figure out 384. Again, I would have pulled out my calculator and just started looking at these numbers that are less than 384 and said, what goes into 384? And you should have figured out that it's 64 and 6. I can simplify the square root of 64 to 8. I'm going to drop everything else. 4 times 8 is 32. 32 times root 6 is just 32 root 6. Okay, so today your homework is going to be Radicals 1, the homework sheet 1, and only problems 1 through 12. Also in class you are going to be doing a puzzle. The whole class is going to, or actually your groups are going to be doing a puzzle together. And it's just, again, simplifying squares. Okay, have an awesome day. Thanks.